Physics is the study of matter and energy and the interaction between the two. And the first branch of physics that we're going to look at is called kinematics. Kinematics is the study of motion, but it's the study of motion without regard to what causes the motion. Does anybody know what causes motion? You're not moving right now. What would cause you to start moving? What has to happen to get you moving? It's a force, yeah. We're going to learn about forces in the next unit. Today, and for the next few weeks of this unit, we're not going to pay any attention to forces because kinematics is the study of motion without regard to the forces that cause the motion. It's the motion itself. We're not interested yet in what causes the motion. That comes later on. And before we get heavy into kinematics, we have to refresh your memory on a couple of terms that you would have done in Science 10 called vectors and scalars. Who knows the difference between a vector and a scalar? You guys remember doing this in physics, or sorry, in Science 10? You remember those terms? You remember hearing those terms at least? Yeah? Anybody think they know what the difference is? If you're wrong, that's okay. Brianne? Good. One of them has a direction, one of them doesn't. So one of them is a quantity that has only magnitude. Do you guys know what magnitude is? Like a size, an amount. It tells you how much you have. And one of them is a quantity that has magnitude and direction. So an amount, but also which direction that amount is. Do you know which is which? Yeah, good. Scalar is just magnitude, and vector is magnitude and direction. Let me tell you a little story here. It was about, I don't know how many years ago it was, a number of years ago. My wife and I are shopping at No Frills. It wasn't called No Frills at the time, but Extra Foods it was called. So we're grocery shopping at No Frills. And I'm not a big fan of shopping at all, especially grocery shopping. So sometimes when we would go grocery shopping, sometimes I just kind of try to find things to entertain myself. Because I don't really like looking for stuff to buy. So I entertain myself. Sometimes I people watch, and sometimes people are kind of odd. But sometimes I people watch. Sometimes I just read things and, go exploring. And this one day, for whatever reason, I thought that reading the labels of all the cereal in the cereal aisle would be more interesting than actually shopping. I'm not sure why, but it turned out that it paid off. Here's what I found, just by random chance, as I'm shopping or as I'm reading labels in the cereal aisle. I'm reading all these different labels, and look, they all give you nutritional information on it. They all tell you, why this cereal is better and so on. But as I'm going through, I find vector cereal. You guys ever had vector cereal? Okay, I've never actually ate it. Is it good? Is it? I've never actually had it, but I bought a box, and I bought a box because vector cereal was the only cereal in the aisle that not only told you the size of the box, 400 grams, but also on the side of the box tells you the directions for use. Just in case you don't know how to eat this cereal, vector cereal gives you directions for use on it. And here's what it says. Place vector in a bowl. Add milk. It tells you how much, but my question is, well, what's next? Spoon, exactly. They don't tell you that, right? Now, listen, when we're talking about vectors and scalars, and we talk about direction, we're not talking about how to do something direction. We're talking about east, west, north, south, up, down, left, right, that kind of direction. This is not a vector because it gives us a direction. But listen, it's a way to remember which one is which. Okay? You don't remember, you remember that one of them has magnitude, one of them has magnitude and direction, but you can't remember which one's which. Vector serial has magnitude, the size of the box is 400 grams, and it has direction on the side of the box. Vector has magnitude and direction. Scalar has only magnitude. By the way, this box of cereal that I have is the one that I bought that night. It expired on November 13th, 2003. You probably don't want to steal this and eat it from me. A vector is a quantity with magnitude and direction. Listen, if I give you a quiz on this and I ask you for an example of a vector, don't tell me vector serial. It's not an example. It's a way to remember what's a vector and what's a scalar. A scalar is a quantity with only magnitude. Again, remember, magnitude means an amount. It has only an amount. Whereas a vector has an amount and a direction. Not how to do something direction, but north, south, up, down kind of direction. Make sense? Kind of coming back to you now from last May or last December, whenever you did this? There are three quantities that I want to talk about here, and hopefully we have a chance to talk about all three of them here today before class ends. And then once we're done that, we're going to wrap it up for the day here. Distance, position, displacement. Don't worry about these last three rows. They come tomorrow. We're going to define all three of these things. We're going to give you a symbol for it, because when we're doing stuff in physics, we don't want to write out the word displacement every time. We want to have a symbol for it so that it's shortened up a little bit. Saves us a little bit of time and effort. The units for it, and we're going to talk about whether it's a vector or a scalar. Define it as a vector or a scalar. Distance, that's a pretty easy one to define, right? How far something moves. Moves or has moved. The symbol for distance is going to be delta D. Delta is a Greek letter. Does anybody know what that Greek letter delta means for us in science? Yeah, it's change, right? If you've moved, then where you are has changed. So that's why we call it delta D. The distance traveled is delta D, the change in where you are. The units for distance will typically be, although there's lots of units that we can use, the units will typically be, you want to take a stab at it? Typically going to be meters. Sometimes we can use centimeters, sometimes we can use kilometers, sometimes we can use miles or yards. But the typical units, the units that you use if in doubt, go to meters. And distance is a scalar. There is no direction associated with distance. When I get in my car and I drive the 1.7 kilometers to school from my house, the odometer on my car, or the trip meter on my car, reads 1.7 kilometers. It doesn't say 1.7 kilometers to the northeast, because that's what it would be if it was a vector. It would say 1.7 northeast. It says 1.7 kilometers. The distance that I travel to school is not directionally dependent. Okay. If I was to go 1.7 kilometers the other way, my odometer would say the exact same thing. Distance is a scalar. Position is where something is. Not how far it's moved, but where something is. And the symbol for position is a D without a delta, but it's got a little arrow over top of it, a little half arrow. Anybody know what that little half arrow means? Okay, we'll get to that in a second then. The units are going to be meters. Again, you can use centimeters or kilometers. A lot of times you can. But the standard units are meters. If in doubt, go with meters. And finally, vector or scalar? Does it matter? Does direction matter when we're talking about where you are? If you're driving your car and you get a flat tire, and you call your dad and say, Dad, I got a flat tire. And he says, where are you? I'll come and get you. And you say, oh, Dad, I'm 17 kilometers from Dairy Queen. Dad's going to say, what? Like where? Like what direction? Like where do I go, right? You're not giving your position if you say you're 17 kilometers from Dairy Queen. You're 17 kilometers west of Dairy Queen. That'll tell him, right? Or you're 70 kilometers to the south. If you want to give your dad your position so he can come and help you with your car, you need to tell him not only the distance you are away from Dairy Queen, but the direction as well. If you want to give him your position, you got to make sure you give him both magnitude and direction. So position is it's a vector. Where you are, your direction matters if you want to tell somebody where you are. And the last one, then we'll wrap it up and do some examples tomorrow. The last one, displacement. This is the change in position. This is the change in where you are. You were 17 kilometers south of Dairy Queen when your car broke down. But then you walked 1 kilometer to the south because you saw a gas station off in the distance. Your change in position, your initial position was 17 kilometers to the south of Dairy Queen, but your change in position was 1 kilometer to the south. It's what your position changed by. Oh, you guys are smart. I can tell that looking at you. What do you think the symbol for displacement is? You got to think about this one. If you do, you can get it. Kelly? No? No, good guess, though. Yeah? Good, perfect. Look, it's change in position. So it's going to be position, but with a little delta in front of it. Because it's change in position, right? We established that delta means change, and we established that D with the arrow over it means position. What do you think the units are going to be? Meters. And a vector or scalar? Yeah, it's going to be a vector. Okay, there's a couple ways that you can figure that out. First of all, if position is a vector, then the change in position will be a vector. The other way, hey, you ever forget this, by the way? Check your data sheet. Look at your data sheet. You got all kinds of equations that you're not going to recognize. That's okay. Look for displacement. When you find displacement, you see it has a little half arrow over it. What does that half arrow mean? It's a vector. If you get a question on a test, is it a vector or a scalar, and you can't remember? Cheat. Look at your equation sheet. If it has a half arrow over top of it, it's a vector. If it doesn't, it's a scalar. Got it? Okay, we'll wrap it up there for today.